Hello everyone, welcome to this session. In the last session, we have shown the GA working flow user example. So in this session, we will go a bit deeper. So in this session, we will concentrate on the representation, the initialization, and the selection. So before that, let's have a review of the workflow of GA. So in GA, the first step, we do the initialization, then we do the selection based on the survival of the fittest. The selected mating pool is here. It will undergo the crossover and mutation to generate a new population. So it's here, and this one will replace the old population. If the stopping criterion does not bite, we will iteratively do this process until it's bite. Then we will have the optimal solution. Okay, so the first thing to talk about is the initialization. And for initialization, the first question to ask is how to represent the data, right? The candidate solutions. So normally an individual is encoded with some data structure. There are different kinds of them. So in the last example, we use the binary string. So you can see this is a binary string of 3, right? So altogether, this binary string, we call it an individual. This is a solution. And for each element of it, we call it a gene, right? A gene. So this binary string, we can decode it into 3, and 3 can be encoded into the binary string, right? So this is using binary string structure. And we can also use other representations according to problem. So for example, the traveling salesman problem, that is a permutation, right? One is a design problem, we can use a real number, and there are many kinds of them. So here is an example of the permutation. So this is a permutation from 1 to 7. So how to generate a random permutation? So we have discussed in the first course of this specialization, the MATLAB part. So you can check it or on Google. So after we know how to represent a solution, we will talk about the way to initialize the initial population. So GA needs to start from an initial population. The population is a set of individuals. So when we talk about a set of individuals, there are 2 essential questions that must be considered. First is that how many individuals are there in the population? So this is a population size. Population size. This one does matter. It highly influences the performance of GA. But in this introductory specialization, we won't talk about the details of how to set the rule to set the population size. Instead, we will discuss it in the next specialization, advanced course. And the initialization method, we need to understand how to obtain the initial population, right? This is the second thing to be talked about. So as can be seen from the last example, what we did is that we use random sampling, randomly select individuals from the search space. That one, using that, we composed the initial population of this, right? So in reality, we can do that for each individual, we can randomly select 1, 0 in each digit or for each gene, right? Then now we get the initial population. The next step is to do the selection. So selection based on the survival of the fittest. So what does this mean? What will this lead to the GA? So first, the selection decides which individual will go to the mating pool so that his gene will be inherited and will be propagated to the later populations. Second, the selection, we need to provide more chance for what? For better individuals, right? More chance for better individuals. That is the survival of the fittest. So what is better, what is worse? How to define that? So this is defined by the fitness function. So this is a new concept. So what is the fitness function? The level of fitness to the environment, right? So if we are doing a maximization problem, so the objective function itself can sometimes be the fitness function. So the higher fitness, the better, right? So when we know the fitness, we can do the selection. There are several kinds of selection methods. So here I list a few of them: the proportional selection, the tournament selection, and the truncation selection. So later we will talk about the proportional selection. Right? So let's see the same problem in the last session. So when we do the proportional selection, we mean the probability of an individual to be selected and become a parent is proportional to its fitness. So mathematically, we can use this formula. We can see this is the fitness of the xi, and here is the fitness of all the candidates. So as we can see from this formula, the higher fitness one will have a higher probability, right? Because this one is all the same for all the individuals, right? Okay, so just based on this formula, we find the fitness and the probability to be selected of the initial population. And we can see the best one, 56, have 55% to be selected, and the worst one only have 1% to be selected. So that's why after the selection, this one was eliminated and this one was selected twice. So, but after we get the probability, we still didn't finish the selection, right? So we need to some way to make use of this probability. And the way that we are going to talk about, we call the roulette wheel, right? So this is a wheel. And each individual occupies a part of the wheel, and this part is proportional to its fitness. So in this way, we can make the fitness be represented, and when turning the wheel, when you stop, it will point to one of the individuals, right? So then how to do that? In a program, we can do it like this. So we can first compute several breakpoints, so milestones, or we call it. S1 is the objective function of the first one. S2 is the first one plus the second one. Then we plus the third one. We plus all of them. So in this way, we have 0, S1, S2, S3, S4. Then we will generate a random number between 0 and the sum, right? So if this random number is smaller than S1, individual 1 is selected. If it's between S1 and S2, individual 2 is selected, and so on, right? So we can find in the to the proportion of the individuals, then the corresponding individuals will be selected. So just based on this, for the example, we found that this one was selected twice, and the last one was eliminated, and the other one are selected by once, right? So this is the result. Why it happens like this? Knowing the selection process, we need to understand the effect of selection, right? So clearly, after selection, better individuals tend to have more copies. For example, in that case, the best one have 2 copies. And when we consider the effect of selection or any other operators in GA, we need to consider 2 things. One of them is called optimality, and the other one is called diversity. As we can see here, considering optimality, the mating pool is larger than the previous population, means it's better. This means the selection guides the search into a promising area in the search space because it eliminates the bad ones and remain the good ones. On the other hand, the diversity of the mating pool is smaller than the previous population. As we can see in the previous population, there are 4 different candidates, but in the mating pool, there are 3 different candidates. So the diversity is important, not to make the GA to be tracked in the local optimum. So later we will discuss more about this. So we can see the optimality improved, diversity decreased. This is the function of the selection, or the effect of the selection. Then a question for you. So if my GA happens like this, I only have one operator, and that is selection. So for the population, I do the selection, then I get the mating pool. But I don't do anything else. I use the mating pool to replace the original population. We do this again and again, iteratively do this. My question is that at last, what will the numbers in the population? What are they? So eventually, all of them will be in the population will be the best one in the initial population. Why? Because survival of the fittest, the mating pool has the best probability, the possibility to select the best one. And again, eventually all the things will become the best one in the initial population. So no better one will be generated. So this means only use selection. We can't solve the optimization problem, and we need crossover and mutation. So that will be discussed in the next session. Okay, thank you very much. That's all for this session. Bye-bye.